undergone to get ready for launch. And we'll also look at some animation of the LCROSS spacecraft and some of what it's going to be doing during the mission and the purpose of why we're doing LCROSS. So, John, welcome.
Thank you.
And if we could, we'll go ahead and roll this very short clip of LCROSS that was taken out at Astrotech. So if we could go ahead and roll that first video.
Okay, this is a look at the, I assume this is the spacecraft being transported from or to, I think it's to the Astrotech facility here. So as it goes in there, it readies or preps for launch as it enters Astrotech. This is where they put the spacecraft together at this point, and they stack it together with the LRO co-manifested mission that goes with us here. And you can see the technicians here. It's on the transport right there. This is the LCROSS spacecraft. It's wrapped in MLI, as you see there. And there's our wonderful logo on top of the fairing there. That's the fairing that will be enclosed in. So, okay, so here it is. Here's the picture of the stack. This is the money shot where LRO sits on top of LCROSS. And you can see the panels there. We have essentially 6 panels around the spacecraft. I'll tell you a little bit more about it here in a second.
Tell us a little bit the kind of things that LCROSS had to do at Astrotech to get ready.
Well, we first had to do like the preparations in order to wrap with MLI and things like that to you get the tank prepped and all the electrical checks and the system checks that had to go with that, and we also checked it out with our Mission Operations Center out of NASA Ames Research Center. That's where the mission will be flown from.
Well, we've got another short video here that we're going to look at that kind of shows very quickly what the purpose of LCROSS is. So if we could go ahead and roll that, we'll have...
Yeah, so typically this would be a very bad ending to a story, but in our case, we meant to do that. So LCROSS's mission is to search for water in one of the lunar poles on the moon. So, as we get in here, if we can roll this next video here, though, I can start telling you more about the mission and the spacecraft itself.
All right, and
so here is a look at the LCROSS spacecraft. It's based around an ESPA ring architecture and a EELV secondary payload adapter. And on there you have these secondary structures which we attach all our electronics. You can see the solar array up there, and you'll see the electronics and the star tracker hanging down there, and our payload or our instruments hanging there on the 6 panel. We're launching out of Space Launch Complex 41 today in about an hour. It's very exciting. About an hour after launch, LRO, which is stacked on top of this, will separate. LRO is now on its way towards the moon, in which it will get commissioned. About 4 hours after launch, the Centaur hands over control to LCROSS. LCROSS becomes a shepherding spacecraft. We then do a lunar flyby and go into about a 4-month orbit. We orbit for 4 months so that LRO can get into commission and get the data, get necessary data for helping us target the crater. We come in 4 months later, target the crater, and we go into the South Pole, as you see right there. Now, about 30 days before impact, the science committee meets, figures out which target to best select at that point on the South Pole. And so the targeting, that's about 30 days before impact. So about 4 hours before, or 9 hours before impact, we turn the Centaur, the upper stage, around, and so that it's pointed towards the crater of interest that we've chosen. Then 9 hours before impact, we will separate from the Centaur, and then we do a 180 turnaround so that our cameras start pointing towards the Centaur as it goes in. Now, we essentially want to slow down. We want to get this 4-minute delta behind us, so that the plume that will evolve as it actually hits takes a couple minutes to evolve. So we timed at 4 minutes as we start to go through it. So the Centaur is on its way. There's nothing more we can do. We've guided it into a crater that 20 to 30 kilometers in diameter. Centaur goes in for the impact. The plume evolves will rise about probably 10 kilometers. The shepherding spacecraft is flying through, and we have 4 minutes to get that data real time down to Earth. And we'll be looking for water ice, the abundance of water ice. We'll also be looking at regolith properties. So as you see it, we're going through the plume here in our 4 minutes of glory as we go through an impact possibly within a kilometer of the same impact. Ground observatories, the Keck Observatory in Hawaii, and all the and astronomers all over the United States. It's going to be a very exciting day for them. They look from the ground. So in the end, LCROSS will be a smashing success.
And Lunar Reconnaissance Orbiter is actually going to be watching some of this.
They will fly. LRO will fly over the impact. They'll be using their instruments to, look at the impact as well. And we also have the Hubble Space Telescope turned around and looking at us as well.
Oh, Hubble will watch too.
Yeah, Hubble. So we were all for it when they were repairing that, and we go Hubble.
So, and it's about how long from today until our LCROSS payload arrives at the moon?
It takes about 4 months. So that 4 months is essentially gives LRO time to get into commission and start collecting data so that it would help us better select which crater we select. Right now, we're currently targeting the Cabeus region in the South Pole, but if better data comes along, then that would help us with our selection at that point. And that 4 months, that long orbit that you saw, also helps us get a very steep impact angle so that the plume efficiently ejects straight up instead of maybe out at angles.
And this particular launch phase that we're in right now, these 4 days, I guess you've had spent some time trying to identify what's available for you to look at during these 4 days. Is that right? In other words, what are your targets going to be?
Well, the science team has spent the last few years looking about what's going to be available as targets and stuff. There's been radar data come in. There's also data from the Selene mission and things that the science team have used to help better understand which crater to target. And it all depends on what time of the year we go. It also helps determine which pole to go to, because the moon librates, and whichever part of the moon is more facing the Earth, that's the one that we tend to favor at that point. That's why it's more observable that way.
Oh, I see. Well, John, thank you very much, and we're going to be looking forward to that point as well. A lot of amateur astronomers as well as professional astronomers will be watching that very, very closely.
Yeah, it's very exciting, and we can't wait. It's going to be a great night. October 9th is the current targeted impact night.
Well, John, thank you very much for coming by and talking with us.
Thank you very much, George. Thank you.
And we're at 1 hour, 50 minutes, 50 seconds and counting. This is Atlas Launch Control.